This is a quick introductory video on rules for calculating derivatives. If you want to see full videos on this and other topics from calculus, go to www.centerofmath.org, and we have videos up for every calculus topic you could want. They're free. But this is just going to be a quick introduction to rules for calculating derivatives. This basically is a chapter of a book in 10 minutes. I'm not going to put up all the rules, but I'm going to put up a lot of them, or I have put up a lot of them. There's the derivative of a constant is 0. The derivative of just the function f of x equals x is 1. The derivative, this is the power rule. The derivative of x raised to a power, the exponent comes down, so the power comes down as multiplication, and you subtract 1 from the exponent. This is called linearity. It means if you've got some constants multiplied times functions, and the functions, those constants times functions are added or subtracted, then the derivative of that just splits up into the easy, I left out a minus sign. The derivative of that, you can pull out the constant, pull out the constants a and b and just take the derivatives of the more simple functions f and g. So we usually say you split up the sums and you pull out the constants. Then there's how derivatives work with products. This is called the product rule. The name isn't supposed to be mysterious. It's a rule about products. The derivative of the product of two functions. You'd like to, if things were as easy as they could be, it would just be the derivative of f times the derivative of g. That's wrong. Why is it wrong? Because you actually have to prove these rules from the definition of the derivative. So you do that, or someone does that. It's been done. And you get this rule, that the derivative of the product is the first thing times the derivative of the second plus the second thing times the derivative of the first. I suggest you not memorize it with the function names f and g in there. You'll just get confused in other problems. I suggest memorizing it the way I said it. It's the derivative of a product. It's the first thing times the derivative of the second plus the second thing times the derivative of the first. This is the quotient rule. It's not very well liked. People have trouble remembering it. The derivative of a quotient of two functions, it's the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. Don't forget this minus sign. This tells you how to differentiate the composition of two functions. So you do one function to x, and then you'll do another function to that result. This is called the chain rule. The derivative of f of g of x is you differentiate the outside function, leaving the inside stuff exactly how it was, but then you have to multiply times the derivative of the inside stuff. Then there are a number of special functions that have their own, that just have special derivative formulas. So like the derivative of e to the x. E to the x is very special. The derivative of e to the x is e to the x. Don't confuse this with the power rule. In the power rule, the base is the variable and the exponent is a constant. Here, the base is constant and the exponent's variable. Those are very different. It's absolutely wrong to take the derivative of this and say it's x e to the x minus 1. It's a common mistake, but it's awful. The derivative of the natural log of x is 1 over x. The derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. Don't forget that minus sign. The rules that I'm leaving out, I haven't given you the derivative of the derivatives of the other four trig functions or the inverse trig functions, but this is enough for us to do some examples. Before I do some examples, I should say one special thing about the chain rule. The chain rule looks like this. The derivative of the composition of functions. You take the derivative of the outside function, you leave the inside stuff the way it was, but then you multiply times the derivative of the inside stuff. In the other notation for derivatives, the one with the d's in it, Leibniz's notation, this becomes very much easier to remember. It looks like cancellation of fractions, and that is more or less how the proof of this goes. That this is what the chain rule looks like in Leibniz's notation. It looks like these du's cancel and you end up with dv dx. That is not exactly what's happening, but it makes things very easy to remember. I remind you, this is just different notation for the derivative. This is the derivative of v with respect to x, the derivative of v with respect to u, and the derivative of u with respect to x. You read this, dv dx, not over. You don't say dv over dx. dv dx equals dv du times du dx. You don't say over because the derivatives themselves are not fractions. They're limits of fractions, but that's different. All right, so how do you use all these rules? Well, the power rule, for instance, would tell us what's the derivative of x squared. By the power rule, you bring the exponent down as multiplication and you subtract 1 from the exponent. So you get 2 times x to the 1, that's just 2x. What about the derivative of 1 over the square root of x? Oh, well, algebraically, you write that. That is the same as x to the minus 1/2, and you're taking its derivative. Right? 1 over the square root of x and x to the minus 1/2 are the same. The power rule still applies. You get minus 1/2. The exponent comes down as multiplication. You subtract 1 from the exponent. So that's minus 1/2, minus 1, so that's minus 3/2. So you get minus 1/2 x to the minus 3/2. We like the power rule. The power rule is our friend. It's easy. And it's powerful, but that's not why it's called the power rule. You can combine a lot of these rules and differentiate very complicated things. So for instance, let's just use the power rule in linearity or several times. Like, let's differentiate 5x cubed minus 7 times the square root of x plus 15. What's the derivative of this? By linearity applied twice, you can split up the sums and pull out the constants. What does that mean? It means that this is the same as 5 times whatever the derivative of x cubed is, minus 7 times whatever the derivative of the square root of x is, plus 15 times, think of this as 15 times 1, 15 times whatever the derivative of 1 is. Or you don't have to do this. You could do this, and it would reduce you to having to know the derivative of 1. But 15 itself is a constant. We had a rule for that. So let's just leave it as the derivative of 15. So what do you get? You get 5 times, use the power rule here. You get 3x squared. You bring the exponent down, you subtract 1 from the exponent. Minus 7 times, what's this? Oh, the square root of x is x to the 1/2. If you use the power rule on that, you get 1/2 x to the, you subtract 1 from the exponent, to the minus 1/2. And the derivative of 15 is the derivative of a constant, that's 0. So this is your answer. You can neaten this up, write it as 15x squared minus 7/2 times 1 over the square root of x, and don't write the plus 0. But that's what you do. What about the chain rule and the product rule? Well, it's just, suppose we want the derivative of e to the x times the sine of x cubed, let's use a different power, x to the 5th minus 7x squared. Oh my God. How do you differentiate this? You have to combine a bunch of the rules. So this is the product of two functions. It's e to the x times the sine of this, times the sine of x to the 5th minus 7x squared. So you can use the product rule on this. It is the first thing times the derivative of the second, plus this whole second thing, the sine of x to the 5th minus 7x squared, the second thing times the derivative of the first. All right, so that's made our problem slightly easier. But now you have to calculate these two derivatives. How do you do that? This is the chain rule here. This is one function done to another function. You differentiate the outside function, leaving the inside stuff exactly how it was. But you have to multiply times the derivative of the inside stuff, which by the power rule in linearity is 5x to the 4th minus 14x. And then you put in this other part, plus the sine of x to the 5th minus 7x squared. And then times the derivative of e to the x, but the derivative of e to the x is e to the x. Yes, you can differentiate very complicated things. It gets long, but just do it in manageable pieces. If you want to know more about this and see many hours worth of videos on how to use these rules, go to www.centerofmath.org. All the videos are free and they will help you.